Okay, so video 4, back at it. Let's see. We already did this problem with all of these numbers. Okay, so here's the problem we're on. Right, so how many pounds of saturated HCFC22, right, pay attention, it's not ammonia anymore, use the right table, liquid, HCFC22 liquid, at 150 degrees Fahrenheit will this line hold? Okay, so we are given cubic feet, right, of HCFC22 liquid, and we need to see how many pounds that will be at 150 degrees Fahrenheit. Okay, so all of these are just different ways to word the exact same problem we've been solving. Okay, we are just converting. Okay, we are just seeing how many pounds of HCFC22 liquid at 150 degrees Fahrenheit will fill this container of 0.12 cubic feet. Okay, this pipe of 0.12 cubic feet. Okay, so all we have to do is same thing. So 0.12 cubic feet. Okay, we are looking for pounds over cubic feet, right? So, and we are going to have to scroll a little bit though, because right now we are on the ammonia tables, right? I told you at the beginning to make sure you guys are using the correct tables. So, boop-a-doop-a-doo. Down here, oh, look, we're in HCFC22 now. What temperature are we operating at? 150 degrees, right? Which is actually past the operating range of most ammonia systems. So that's something to keep in mind. If you're getting up there on the numbers for temperature, and you're wondering like, where is 100 and 200 degree ammonia, and you're not finding it, you could be on the wrong table. So 150 degrees. Okay, we have right here 150 degrees HCFC22. Okay, and we're looking for pounds per cubic feet of liquid. Pounds per cubic feet of liquid is going to be the density of liquid. Alright, at 150 is 62.4. So, 62.4 pounds per cubic feet, right? Feet cancels out, we're left with pounds, that's what we're looking for. Multiply that out, so we have 0.12 times 62.4 equals 7.488. Our answer is going to be 7.488 pounds of HCFC 22 liquid. Okay, that's how many pounds this line will hold at that temperature. 7.488, look at that. Alright, next. Ammonia vapor at 76 degrees Fahrenheit and 26.1 inches of mercury vacuum. Okay, so we're operating at vacuum. Alright, it's ammonia vapor. Is at what condition? Okay, in one of the earlier questions, we went over what conditions it can be at. Okay, so we can have saturation. Okay, we can have superheat, and we can have subcool. Okay, so let's look. Let's open our tables. I'm going to move this one over here for this problem. Okay, we need to go back to ammonia, our ammonia tables. All the way up here. And we're in vacuum. So, let's see. Oh, this is actually negative 76 degrees Fahrenheit. It didn't transfer over to PowerPoint very well, but this is negative 76. Let me just make sure we have that established. Negative 76. I was like, that's kind of a weirdly high temperature. Okay, and we are at 26.1 inches of mercury. So let's look and see. That is strange. Where did I get the numbers for this problem? Oh, you know what? I bet this is in the other tables and not in this one. We're going to go ahead and skip this problem for now. And we already did an example like this, so I'm not super stressed about it. But we'll go ahead and skip this one, okay? There's the answer. Because this table doesn't go back that far to those values, which is another reason why I like the other table. But it's not the one you guys are going to be given on your test. Okay, so here is another PSIA and PSIG problem. You've got to be able to convert back and forth, okay? It's not super hard, but it's just something you got to know, okay? So I advise, like I said, drawing the thing every time. 0 PSIA, okay? 0 PSIG, and then it is equal to 14.7 PSIA. Okay, so 139.8 PSIA. Okay, so from PSIA going up, that is 139.8. Alright, and we're trying to convert that to PSIG. So to convert that to PSIG, we are going to see what this is. Okay, so this is 14.7. Okay, so from the 0 PSIG line, so we're trying to find what this right here is equal to. So all we have to do is subtract this from it. Alright? So 139.8 minus 14.7 equals 139.8 minus 14.7 is 125.1. So we have 125.1 PSIG. Is that correct? Yes, it is. Of course it is. I know what I'm doing. Alright, next problem. Saturated liquid ammonia at 65 degrees Fahrenheit weighs. So weight or mass, we're looking for pounds. We have saturated liquid ammonia. Okay, so this one, all you have to do is really reference your table. So saturated liquid ammonia, okay, ammonia table at 65 degrees Fahrenheit. We know it's at saturation because it just told us, so we can use our saturation table. We have 65 degrees, and we are looking for, it says how much does it weigh, okay, but we can give the density because it doesn't give us a specified volume. Okay, so we just give the density of liquid. Okay, so that is going to be 38.29 pounds per cubic foot. That's your answer. Right? 38.29, 38.25, table differences. We're good. And our last problem, we have 200 pounds of saturated liquid ammonia at 85 degrees Fahrenheit, and we are seeing how much space it occupies. Okay, so another word for that, how much space it occupies, would be volume, right? Which we measure in cubic feet. Oh, wrong slide. Don't look at the answer. Right? Which we measure in cubic feet. Okay, so but we have 200 pounds of saturated liquid ammonia at 85. Okay, so this is once again just converting pounds to volume, right? So we have 200 pounds, right? We're going to look for cubic feet per pound so that we can cross them out and get our correct unit. Now, what is cubic feet per pound? What unit are we going to use? If you said specific volume, you would be correct. So saturated liquid ammonia, 85. So let's look for 85. Ooh, it's right here. All right. So 85 degrees, we're looking for the specific volume of liquid, because it said that in our problem. And that is going to be 0.0268 cubic feet per pound. So 0.0268 cubic feet per pound of liquid ammonia at 85. So now, same as we've done 600 times, cancel out pounds, we're left with cubic feet. 200 times our conversion factor there, times 0.0268 equals 5.36. So our answer is 5.36 cubic feet. Okay, so if we have a container, all right, of liquid ammonia at 85 degrees Fahrenheit, okay, and we weighed that container and saw that it weighed 200 pounds, okay, the ammonia did, the volume of that container would be 5.36 cubic feet. And that is all the problems I have in this. So, have a good day.